Hey guys, welcome back to Rocket Gyan, my fellow space tubers. Okay, we are here again to witness another launch, and this time it will be the Atlas 5 rocket carrying the Ghost T satellite. First of all, I must give credit to 321 Launch for providing these live views. So, uh, to check out his channel, and right now you are seeing that the Atlas 5 is on the pad and is venting some liquid oxygen right there, which means everything is looking fine on that part. Hi everyone, hi Wildflower, welcome to the stream. Hi Eldona, welcome. Andrew, find the bug. I'm looking forward to this launch, and hopefully you all are too. Um, okay, just a second. Yeah. So So today's launch is done by ULA, and interestingly, this is the second launch of 2022 for ULA. ULA, as you know, does not launch frequently, but here you can see that they are launching it very frequently now, and everything seems fine for now. And this will be their second launch, and this is the Ghost T satellite, which will be launching the geostationary orbit. And yeah, we'll talk about the rocket, we'll talk about the satellite, so everything will be there on the stream, so you don't have to worry about anything else. Pumped for this launch. Yes, I am out too. So let's get to the things here. So we have, let me just have the view of the rocket also going in. And Just a So we have this Atlas 5. This is the actual image of the Atlas 5 which will be flying today. This is the Atlas 5 in a 541 configuration, or you can say AKA the Dominator, as Mr. Tori Bruno always mentions it. Here, this is a very beautiful looking rocket. As you can see, a golden core, and then the boosters attached, and then the second stage in this fairing. And this fairing is actually very large, which you can see also here. And yeah, so talking about this rocket, so this rocket is, you can say, yeah, this is the exploded view. So as I said, this rocket has the core stage and the boosters attached. So as I said, this is launching with the 541 configuration. 541 configuration means the 5 means the it is carrying the 5-meter fairing, which is the larger fairing, which here 4 means 4 in 541 means that there are 4 solid rocket boosters attached, and then 1 in 541 means that only one RL-10 engine will be flying today. This configuration, uh, everything all right? Oh no. Okay. Yeah, so this you can see in front of you. The first stage is powered by RD 180 engines, and as you know, right now there is some tensions going on between Russia and in USA. So RD 180 engines are basically Russian made. Thankfully, though, all the RD 180 engines which are necessary for the Atlas 5, there are like 25 flights left for the Atlas 5. All the RD 180 engines are in US right now. And yesterday only, Mr. Rogozin, he's the Russian space chief, as you can say, and he tweeted out that they will not be supplying the Russian engineers for the Atlas 5 launch, and which means the Atlas 5 will need to be launched solely on the expertise of ULA engineers and Tori Bruno. And this is what has happened, and Tori Bruno has given the reply also. I asked him, like, please clear the doubts of Mr. Rogozin. He said he likes to have the Russian engineers for consultation if anything goes wrong, or if anything unexpected comes up. But he and the team has the expertise of flying this RD 180 engine for so long now that they can handle most of the cases. So that's what his reply was. So yes, we shouldn't be seeing any problem with the launches of Atlas 5 for now. So that's a great news. And talking about the Ghost T satellite, so let's move on to the Ghost T. Okay, I forgot about the core stage. The core stage is powered by RD180 engine, which runs on RP1 and locks as its fuel. Second stage is powered by RL10 engine, which is, in my opinion, right now the most what should I say, efficient and precise upper stage which is flying today, the Centaur rocket. This RL10 engine runs on liquid hydrogen and liquid oxygen as a fuel. Okay, now moving on to the next part. This is the satellite which is going to the orbit today. This is the NOAA's Ghost T satellite. This is an Earth observation satellite, and it will image the Earth in high definition, as you can see, and basically this is a weather satellite, not Earth observation. This is a weather satellite, and this is the third of the GOES-R series, the current generation of weather satellites operated by National Oceanic and Atmospheric Administration, or known as NOAA. The current and the next satellites of the series GOES 16 and GOES 17 have already been flown, and now this Ghost T satellite is being flown today. This satellite is built by Lockheed Martin, and expected lifetime of this satellite is around 15 years. Okay, so this is that thing, and yeah, we have seen, okay, so these are the steps which arrived. The timeline was in 2021, the Ghost arrived, launch vehicle delivery happened in 2021, 2022, satellite fueling, stacking the rocket, satellite encapsulation, satellite made to the launch vehicle, and rollout to the launch pad. Everything has happened, so this timeline is done perfectly. Now moving on to the actual, you know, this satellite. So talking about this satellite, as I said, is a weather satellite. So the benefits and the application of these satellites are tremendous. This has a better detection of heavy rainfall and flash flood risk, better fire detection and intensity estimation, better monitoring of smoke and dust, earlier warning of the lightning, ground strike hazards, improved air quality warnings and alerts, improved detection of low cloud and fog, improved transportation safety and aviation route planning, improved hurricane track and intensity forecast, improved warning for communication and navigation disruptions and power blackouts, increased thunderstorm and tornado warning lead time, more accurate monitoring of energetic particles responsible for radiation hazard. So this is a very advanced weather satellite going to the space, and as I listed out, these are the all the benefits which it will be having. And let's just listen into this video. You should be able to get most of it out of it.
3, 2, 1.
NOAA is about to launch a new satellite into orbit above the Earth. This satellite will be the third in a fleet of NOAA's latest generation of geostationary operational environmental satellites, called GOES, the most advanced weather observing and environmental monitoring system in the Western Hemisphere. GOES satellites orbit 22,236 miles above the Earth's equator at speeds equal to Earth's rotation. This allows for continuous coverage of weather systems as they move throughout the atmosphere. The GOES satellite system keeps watch over more than half the globe, from the west coast of Africa to New Zealand, and from the Arctic Circle to the Antarctic Circle. Each satellite in the series provides high-resolution imagery in near real time to provide critical information for weather forecasts, severe weather prediction, lightning detection, and solar activity. The latest satellite is GOES-T, which will be renamed GOES-18 when it reaches orbit. GOES-T will be the third satellite in the series and is expected to replace the current GOES-17 satellite in the GOES-West orbit. In this position, the satellite will continue GOES-West's legacy of keeping watch over the Pacific Ocean, the western U.S., and the U.S. territories. It will provide complete satellite coverage for the weather systems that impact Hawaii and Alaska. It will provide critical data over the northeastern Pacific, where many of the weather systems affecting the continental U.S. originate. It will monitor and track tropical storms and hurricanes in the Pacific Ocean. It will help identify and track wildfires across the western U.S. It will assist in search and rescue efforts around the U.S. and its surrounding waters as part of NOAA's SARSAT system. And it will help monitor and track weather phenomena that impact the western U.S., like dust storms, monsoons, marine fog, atmospheric rivers, and more. The GOES series of satellites supports NOAA's mission to provide secure and timely access to global environmental data and information from satellites and other sources to promote and protect the nation's security, environment, economy, and quality of life.
So as I said, this is a very advanced satellite and it has like so many applications. And when a weather satellite goes into space, then it directly affects the life on the Earth, because it can actually improve the life on the Earth by providing early warnings to various natural disasters and whatnot. So yeah, that is the case. And let me just quickly run through the satellite model, which will actually give you the scientific equipments on this satellite. So if I move on to this here, you can see these are the sun pointing equipment. So we have this mag, which is the magnetometer, which will measure the magnetic field in the outer portion of the magnetosphere. Then we have this SUVI, which is the solar ultraviolet imager, observes the active region of the sun, solar flares and eruptions of the solar filaments. And then we have this XS, the extreme ultraviolet X-ray irradiance sensors, which will detect solar flares and monitor solar radiance. So these three scientific instruments will point directly towards the sun. And okay, we have this also here. This will also point towards the earth. The space environment in situ suite, it will monitor proton, electron, and heavy ion fluxes. Basically this radiation detector. This is the radiation detector. So these instruments will point towards the sun. Then moving on and coming to the instrument which is pointing towards the earth. This is the ABI, the Advanced Baseline Imager, which will watch over that Western Hemisphere. And basically it's an imager, so yeah, that is the case. And then we have this GLM, the Geostationary Lightning Mapper, so it will be able to detect the lightning's activities and everything that goes um, on the earth. So you can see this is how it would look like. Okay, now moving to the next part. So as I said, these are the nadir pointing instruments, which are the earth observation. Then we have the solar pointing, axis and SUVI, and then we have in situ, which is not visible. Basically in situ means the magnetometer and says, which means they will just will be on for a certain period of time, and will not be pointed towards anything, just get the reading in its environmental space. Okay. So this is how the satellite looks like when the solar panels are unfolded. You can see that this is how the satellite looks like when it is fully assembled. And now let's just quickly see the mission flight profile. So the flight profile is liftoff, booster separation, fairing separation, MECO, the stage separation, then the second stage engine ignition, then cut off, and then again second stage ignition, then cut off, again ignition, then cut off, and then finally the separation. So you can see we have this engine start, one, main engine cut off, and the second main engine start, then main engine cut off, and the second main engine start. So basically it is going to geosynchronous orbit. So you can see, first of all, it will try to raise the apogee, and once it has done that at t plus 3 hours and 28 minutes, when it will at this point at the apogee, it will try to again light up the engine to circularize the orbit. So this is what it would do. So yeah, that is it. And probability for today's weather condition is just 20% of violating weather conditions. So everything is looking in order. And
You're
now
looking at a view inside the
let
Atlas
me
space flight operation.
just okay.
Is the launch team, and you can see the three levels there, the three rows. This is where all the action is happening.
Yeah, this is the United Launch Alliance team. This is their launch control center, and Daryl, as
So
you said,
the webcast is live, as you can see here. Everything is looking good. We are T minus 32 minutes from the launch, and when they will switch over to the pad views, you will see such a beautiful view of the rocket. And right now things are looking great for an on-time liftoff. In case something goes wrong, we have a 2-hour launch window, so they will be having some launch time to correct it, and then again start for the liftoff, prepare for the liftoff. And most of the time the geostationary orbit launches has a launch window of like 2 to 3 hours, so that's a good thing to have. Here you can see the Atlas 5 on the pad, currently venting, which is completely nominal. And this is the rollout of the Atlas 5.
Coming out of the vertical integration facility and rolling about a third of a mile out to the launch pad. Nick, you were out there. Pretty smooth operation.
Yeah, it was. The team did a great job making that trip about 1,800 feet to the pad, traveling about a half a mile an hour on the mobile launch platform and everything there. And team did great getting that out there and ready for RP1 tanking and then launch today.
You look at the rocket there, and it carries a special dedication today Mick, it holds the name of a former ULA employee by the name of Mark Tim. Mark started his long aerospace career with the Boeing team in 1987, but after a decade in Denver, Colorado, he transferred to ULA's facility in Decatur, Alabama. That's where Mark Tim supported the ULA's fleet of rockets, including the Delta II, Delta IV, Atlas V, and Vulcan. There you see him in the middle, surrounded by NASA astronauts. Mark Tim passed away in 2020, and he's missed by all those who had the pleasure of working with him during his 30-year career in aerospace. And Mick, you knew him.
Actually, guys, as I said, that this satellite will be replacing the already working satellite in the orbit, GOES 17, and it will be replacing that. So there is, a question which will arise there. Why is it replacing it? Is it its lifetime is over or what? The lifetime is not over. Even, in fact, it was launched in 2016, and GOES satellites have like a lifetime of 15 years. But again, it is replacing that satellite. And it is doing so because okay, listen to the weather first.
Canaveral Space Force Station's 45th Weather Squadron. Arlena, this launch weather you're about to report out, forecasted with data from GOES satellites, right?
Yes, that's correct, Megan. In fact, right behind me is a great example of the type of imagery that we get from the GOES satellites. In this case, because we're here in Florida, this is from the GOES East satellite, giving us a great view of what's going on across the Cape and East Central Florida this afternoon. Now, as mentioned earlier, we did have quite a bit of overcast clouds and some low clouds out there earlier today, but as our satellite imagery is showing, we've scattered out pretty nicely with only a few clouds as a concern as we go to the remainder of the launch countdown. The trade-off, however, for those clearer skies and partly sunny conditions is that we do have pretty breezy conditions out there. I'm sure anybody who's outside across the Cape this afternoon is experiencing. And those are going to be our primary concerns as we go forth into the count for the remainder into the launch. Now, if we take a look at the forecast here, we're going to be looking at those pretty gusty northerly winds from about 26 to 32 mile per hour range. Temperatures about on point for this time of year here in Central Florida, where temperatures are going to be in the upper 60s to around 70, which will feel a little bit cool if you're outside with that, but for launch concerns, not a big deal. As I mentioned earlier, liftoff winds are going to be our primary concern, with a smaller concern for some of those passing cumulus clouds. But overall, we have an 80% go for weather, and things are looking good. And so hopefully good launch. Keep our fingers crossed. Back to you guys, Megan and Kevin.
That
all right, you
is
said
a
fingers
good
crossed.
thing
We're
to
doing
hear.
it. Hey,
Yeah.
where are your fingers? Okay.
There we go.
Arlena, thank you again. Quick check of the clock. We are now at L minus about 28 minutes to go before we launch GOES-T. Now, GOES stands for Geostationary Operational Environmental Satellites. Geostationary refers to where and how the satellite will orbit the Earth. So this might be a little difficult to understand unless you see it, right? So this is why we brought some props here today. Kevin, let's start off by just talking about how you determine a satellite's orbit.
So it's really determined by its overall role, right? What is the job of that particular satellite? So in the case of polar orbiters, they typically will rotate along the poles, and their job is basically to image the entire planet as the planet rotates underneath it. So there is a time frame for which they can provide you a global image. And so again, in a low Earth orbit, that is why you'll see those particular satellites used.
But the geostationary orbit, it has to be in a fixed place, so in the sky at all times, right?
Correct. And actually, to achieve that, you have to be 22,000 miles above the planet, and as a result, so it can actually spin with the Earth as it continues to rotate. So relative to your position on Earth, you will always see this particular satellite in its place.
So that's why we say it will keep continuous watch over the Western Hemisphere with a second GOES satellite, right?
Absolutely. So between the two of them, they'll be able to cover this portion of the hemisphere we're talking about, from Western Africa all the way to New Zealand.
All right, and GOES-T will reach that geostationary orbit on March 12th. And now let's take a closer look at the satellite. GOES-T is the size of a small school bus and weighs over 6,000 pounds. It has a 5-panel solar array, which you see there. It's the one that's kind of swinging out. They'll produce more than 5,000 watts of energy, which is the same amount needed to power your home's central AC system. GOES-T has 6 advanced instruments that can analyze weather hazards and environmental conditions. The plan is for GOES-T to replace one of 2 GOES satellites already in orbit that together protect more than 1 billion people in the Western Hemisphere.
Okay,
3,
that was
2,
okay. Yeah. So you just listened to the weather forecast as well as how this satellite will be able to image the Earth, and as she said, it will be going to a geostationary orbit. Let me just try to explain you in more layman terms. Geostationary orbit means the time period of the orbit of that satellite will be exactly 24 hours. So that time period will be in sync with the Earth. So as the Earth rotates below, the satellite is also rotating, going in the orbit at the same phase, and seeing just the same area on the Earth. So that is the geostationary orbit. And yes, as I was saying, that it will be replacing the GOES 17 satellite, which is already in the orbit. And GOES 17 satellite actually had an issue, and that's why this satellite is actually replacing it. The GOES 17 satellite had an issue with its heat pipe. To be precise, let me just tell you. Yeah, so experienced an anomaly when its onboard loop heat pipe wasn't able to sufficiently cool the satellite's advanced baseline imager. This ABI, which is the actual imager which will image the Earth, it wasn't able to, properly cool that imager, and because of that, it was the life of that ABI imager was not 24 hours per day, but just reduced to 13 hours or 12 hours per day. It was supposed to work for 24 hours, 24/7, but it was reduced to just 13 hours per day. And now, once this satellite goes to the orbit, it will replace that satellite. So this is what will be happening today. And talking about Antares, you asked about this, dimensions of the satellite. So as you heard, this satellite, when is fully, deployed, is size of a small school bus. So that must be your scale for this satellite. So this is not only be looking at the Earth and providing information about the weather on the Earth, but it will also monitor the space weather. And that's why it has some instruments pointing towards the sun, which will study the sun to, get the information on the space weather, which is again very much necessary for the satellites.
Let's hear from NASA's Leo Martin.
Thanks, Megan. I'm here with Pam Sullivan, NOAA GOES-R program manager. Pam, thanks for joining us today to give us some insight onto this mission.
Oh, it's great to be here. Thanks for having me.
So we've heard that there are 6 advanced instruments on board GOES-T. Can you tell us a little bit about them?
Sure. Let me tell you about our most revolutionary instrument, the Geostationary Lightning Mapper. It's actually the first time we've had this capability on orbit, and this instrument is watching the Earth, taking pictures 500 times a second to look at lightning. And because it is a new instrument, we're actually learning new and interesting things about lightning as a phenomena. For instance, we've seen that large wildfires can generate their own lightning. And the GLM has also shown us that lightning strikes can be really, really long. For instance, GLM recently measured a lightning strike that was more than 470 miles long, stretched from Texas over to Mississippi.
Wow. And so having that type of information, 500 images per second, that's almost like having maybe like a stop motion film. What can we do with that information once we have it?
Yeah, well, the important thing, of course, is what the forecasters can do with it. And they use the GLM data in conjunction with our advanced baseline imager data and some other data. But they look, when they're wanting to see if a storm is intensifying, they're looking at that lightning signature, and they're looking for what they call a lightning jump, when the amount of lightning strikes increase dramatically, because that indicates that the storm is likely to be becoming more severe and may spawn dangerous tornadoes.
Oh, wow. So we talked a little bit about the location, that this will become a satellite that observes the Western Hemisphere. What part, why is that location significant?
Yeah, specifically, GOES-T is going to go into service as our GOES West spacecraft. So it'll be stationed over the equator, a little bit off of the west coast of the U.S. And as you know, most of the weather in the U.S. moves from west to east. So that western satellite is really important as giving us an upstream view of what's coming.
And here you have the live views of the rocket.
But the other thing, GOES-T will also see dangerous conditions that are particular in the west, like wildfires and smoke, dangerous dust storms, and also the phenomena of atmospheric rivers.
That's incredible. And so some of these instruments that are on board that are advanced, they're actually an advancement from current satellites that are in orbit now. Is that correct?
So the GOES-R series, compared to the previous generation, is much more advanced. The Advanced Baseline Imager generates 60 times more imagery, and then the Lightning Mapper, as I said, is a brand new capability.
Thank you so much, Pam, for giving us some insight into this mission. We're excited to see the launch, and Megan, we're going to go back to you.
Perfect. Thank you so much, guys. You know, one agency actually uses GOES satellite data more than anyone else, and that's the National Weather Service. So joining us now is Chrissy Hurley, who's a meteorologist there for the National Area.
Okay, so wasn't space weather feature already there with other satellite? Does it have new mechanism of space weather detection? Yes. See, again, space weather is very much necessary, and the space weather is different on different location. Space weather is different in LEOs. The space weather is different in geosynchronous orbit. What I know is that we have many space weather satellites in LEO, but GEO we don't have much, and it is always and always necessary to have more and more space weather satellites, because it's like we are having some weather stations around the Earth. So if we have like more weather station, we'll be able to gather more data, and we'll be able to be basically be more precise on our observations. So this satellite is actually will be studying the sun. Those instruments, 3 instruments, will be studying the sun, and while studying the sun, it will be able to identify how the sun behavior is changing, and how those coronal mass injection, which actually plays a crucial role for solar storms or geostorms and all. It will be able to detect that, and necessary precautions could be taken care if those detections can be occurred beforehand. So this satellite would do that. So this is not only a weather satellite, but it's a total package of weather satellites. It is observing the Earth's weather as well as the space weather. So it's good. And in geosynchronous orbit, where you are not actually protected by the Earth's magnetosphere, there the space weather, especially the coronal mass ejection from the sunstorms, plays a crucial role in the health of your satellite. So you need to be very, very you can say precise with your observations, as well as you need to detect them in very well in advance, so that you can save your satellite during that geostorm.
Minutes versus seconds, and seconds really matter.
Geomagnetic storms.
Absolutely. Yeah. Thank you, Chrissy. Now, GOES-T also has the latest technology in detecting and tracking wildfires. A few years ago, one wildfire tore through California at an estimated rate of 100 football fields a minute.
The 2020 Western U.S. wildfire season was historic, both for the record 59,000 wildfires that formed and the 10.1 million acres they scorched. But right on its heels was 2021, in which nearly 52,300 fires were recorded, with more than 7.8 million acres burned through December 24th of that year. Since launching in 2016, NOAA's most advanced geostationary satellites are improving fire weather forecasts, wildfire detection, and fire hazard tracking in near real time. With lives and property at stake, timely, high-quality data is critical for firefighting efforts on the ground. NOAA's GOES-17, operating in the GOES West orbit, has shown its mettle detecting and monitoring wildfires and the hazardous smoke they emit.
There's 2 instruments on the GOES series of satellites which are helpful for wildfire detection and monitoring. The first is the Advanced Baseline Imager, or the ABI. We're able to detect hotspots from the thermal signatures from the fires, and we're also able to detect the smoke and track the smoke with time in order to issue notifications and warnings to the public. The second instrument is called the Geostationary.
How the wildfires look like in space, and those are the lightnings. This is so cool, right?
And so forecasters can monitor the GLM to see where lightning has occurred, to decide whether or not they think some lightning may have started a fire.
But a new satellite called GOES-T is poised to replace GOES-17 in the GOES-West position. Once it reaches orbit, GOES-T will be renamed GOES-18, and it will provide the same sophisticated technology to track wildfires in the western U.S., as well as detect lightning that can ignite a wildfire in parched vegetation.
This current capability
Wow.
of GOES is the
This is how the
fact that we
lightning
can
looks
do
like in
rapid
space.
scans, higher resolution with higher sensitivity, and include things for the first time like Lightning Mapper and the ABI instruments. I don't think we could imagine not having GOES capability. We absolutely need it.
The National Interagency Fire Center is the nation's support center for wildland firefighting.
GOES is an eye in the sky. It's giving us a hemispheric perspective with those 16 and 17 without having those two satellites up there constantly staring, constantly monitoring, constantly providing us with information. We really have just a big gap. We would lose a lot of our capability to understand the environment, to see the interaction of the fires with the atmosphere and see how the atmosphere is impacting the behavior of the fires. With those being able to look at the United States every 5 to 10 minutes, we're getting a much more real-time appreciation for how fires are behaving because of the ability of the GOES satellites to detect the heat from the fires.
Wow, that is truly amazing.
Kevin, we were talking earlier, and you told me that
Hey,
oftentimes
that's
GOES
it.
satellites, even at 22,000 miles above the Earth's surface, they can sometimes detect fires before people on the ground even know that they're there.
Absolutely.
That's so impressive.
It's an amazing capability, absolutely. And we heard from our National Weather Service rep. I mean, right there, that's a great
And
example of
Stephen,
how it
if you
happens.
are living in Florida, you must be able to see this launch. So don't miss that opportunity. And maybe we have like 40 minutes, and if you live nearby, just travel to the viewing area and enjoy the launch, because these rocket launches are like, you should see those rocket launches at least once in a lifetime, and you would actually feel it, literally feel the rocket going up. That vibration is just too intense to ignore.
phone and you want to see the forecast and you're opening up an app, a weather app, that's exactly what you're doing. You're actually using GOES information. That GOES data is going directly into the models that inform you on what the conditions are going to be.
Fascinating. I can't. I had no idea. Here I am just looking, and you never think about where it came from. So thank you so much for telling us about that. We're now L-minus about 14 minutes away from launching GOES-T. Daryl and Mick, it's about time for that launch manager poll you talked about.
It sure is. And before we get to that poll, which is happening at L-minus 13, so just about 50 seconds from now, we got an update from the launch weather officer. You can see on the bottom of your screen the weather briefing there, right there. They talked about the winds. They're still pretty up, but the clouds have dissipated, so we are now at 90% go for launch, improving from that 80% earlier that you heard reported. But Mick, still got a 10% because we are watching those winds.
Yeah, as you can see in the forecast there, where Megan and Kevin are, the winds are still here on the ground, blowing pretty good. The team is continuing to monitor those, but yeah, I'm glad to hear that 90% go.
Those clouds moving,
level, and they will remain green through 2218 Zulu, so significantly into the window. And then we could get a later update should we need it.
Listening to
looks like we have very improved ground winds additionally, so
it's
great for weather. We've had a really good ground propellant load today, and very, very little activity on the range instrumentation. So with that, I would like to now conduct the GOES-T launch poll. NASA CE.
NASA CE is go.
Copy NASA CE, SMA.
Wow, man. We have 90% go for the launch, which means you will see the launch for sure, and Atlas 5 launches are very beautiful.
Copy SMA. SMD.
SMD is go.
Copy SMD. NASA MEM.
NASA MEM is go.
Copy NASA MEM. And LSP.
LSP's go.
Copy LSP. NLM copies. The NASA launch team is ready for the launch of GOES-T spacecraft.
And that was NASA launch manager Tim Dunn that you saw at the bottom of the screen there towards the weather briefing milestone. And so now we're good to go.
Yeah, Chuck, that was a very important. Sorry, Daryl. I'm thinking of that because
You heard
NASA.
Chuck.
I did hear Chuck.
Yeah.
NASA LSP. What I was going to say there is Tim paused at the end there because Chuck Duvall, NASA LSP. This will be his last mission as he just announced his retirement from NASA after 40 years. So this mission, Chuck, goes T. Thanks for everything you've done, and thanks for that go.
Been here a long time. Didn't he start as an intern?
He did.
Yeah.
He did.
It's a long career. Well, congratulations to him. And here we are with the rocket on the pad, ready to go.
This is, will you ever, see this thing happening in any organization where a person joins and as an intern and then goes on to become a manager in the same organization? That does not happen often, but the space organizations are one where you will see these things very common.
Dr. Thomas Zurbuchen, NASA's Associate Administrator for the Science Missions Directorate, and this is a huge year for you and your team.
Absolutely. It's a year of science. Every year is a year of science, we say. You know, like we have an amazing number of launches ahead of us. In fact, Tropics, which is 3 launches. We have Maya, we have Emit, we have JPSS. And you see the theme, it's all Earth science-related launches, some of them in partnership. We also have Psyche, and then first
Nice
light
art.
of the James Webb Space Telescope, as well as many other, highlights this year alone.
Yes, and so many of the missions that you just mentioned are actually tied in to both weather and the environment. Why is that important for NASA and the work that we're doing?
From the beginning, NASA was about exploring the universe, but also exploring and understanding our own Earth and providing service for that. And the launch today, as well as many of the launches in the future, are precisely about that, understanding our changing planet, the system of systems. Everybody we love is right here. Our entire history is right here on that planet. So we want to understand and help protect it as we go forward.
And so the information that we get from these launches, how will we use that?
So the information we get from these launches, we use to get a better understanding in many areas. Of course, understanding, for example, Emmet, about the aerosols that are in the air. Where do they come from? We know they relate to precipitation in many areas. Like, how do they get transported globally? Maya, my daughter has asthma. It's about pollutants, learning from space, how to predict those and provide information for my daughter and the many others that suffer from asthma and so forth. That's precisely, each of them has an application like that, a set of understandings that we want to bring to the table.
Complex science has a very simple application here on life on Earth, for life on Earth. So we also heard that the information that we're going to be capturing from these satellites is going to be available to the public as well.
Absolutely. Everything we do here in Earth science and all over the science portfolio is information that is made public. We want scientists of all training levels, learners of all ages, to be able to look at this. But we also believe it's really important to trust the science. You should be able to look it up yourself and understand it. We think that's a really important part, and we've led that. We're actually moving from open data to open science. So we actually even make in the future the codes available that provide the actual predictions and the information that is there.
It's incredible using this information in conjunction with other information to give us the best picture possible. Dr. Zurbuchen, thank you so much for joining us today. We're looking forward to this launch. I'm sure that you are as well, and we really appreciate you being here.
Thanks so much, Leah. Absolutely.
Megan, we'll send it back to you.
Okay, so this open science concept is actually very, very interesting. Like in software industry, we have this open source concept, which is the driving factor for various computer science enthusiasts or computer science programmers to basically code for an industry or make something out of the community. Like, right, the open source any open source apps, if you have used, there that application is not developed by any company or so. That application is developed by community, by computer science programmers for free, which they do just for fun, just for their passion and those things. And if we have a concept for open science, that would mean we will actually, drive so many students, teachers, scientists in actually evaluating the data coming out of the science, which is wonderful. Now just listen to the mission polling.
Go. Hydraulics. Go. Pneumatics. Go. LO2.
Go.
Water. Go.
Centaur systems, propulsion.
Go.
Pneumatics.
Go.
LO2.
Go.
LH2.
Go.
ASGAS.
Go.
Electrical systems, airborne.
Go.
Ground.
Go.
Facility.
Go.
RFFTS.
Go.
Flight control.
Go.
GCQ.
Go.
Operation support.
Go.
COM.
Go.
Umbilicals.
Go.
ECS.
Go.
Redline monitor.
Go.
Quality.
Hey.
Go.
Ops safety manager.
Go.
ULA safety officer.
Go.
Vehicle system engineer.
Go.
Anomaly chief.
Go.
Range coordinator.
Clear to proceed.
Launch director.
You have permission to launch.
Proceeding with account. ALC, verify T0 is set for 2138 Zulu.
Verified.
And we have a go for the launch, guys. We have been given a go for the launch. Everything looks great. And yes, as I was saying about the open source organization, I have myself contributed to the open source code, and the organization was Polyastra, if I remember correctly. I actually contributed in making that Polyastro was basically is a orbital mechanic simulators software. So there I contributed the code to make a ground tracer for a satellite. So yeah, that was a very fun exercise which I did.
Which is a concern for Florida and everyone along the Atlantic seaboard and in the Gulf states.
Yeah, and I'll be very happy to have GOES-T up there in the west, as Kevin was saying. You know, all weather moving west to east, so getting GOES-T.
Hey, Robert Singer, how are you? Welcome to the stream. I'm back in Kentucky. I'm very glad you are streaming this. Thank you so much. Appreciate it. And guys, if you are just joining in, let me just tell you, we are seeing the live views of the rocket Atlas 5 in a 541 configuration. 5 means the 5-meter fairing, 4 means we have 4 SRBs on the rocket, and 1 means we have 1 RL-10 Centaur engine. Okay.
Network, and I am so excited for the GOES-T launch. Meteorologists and weather anchors like me across the country depend on GOES data to bring you your daily weather forecast, but also to keep you and first responders safe during severe weather events. Accurate and timely forecasts are crucial, and that's not possible without satellites like this one. Godspeed, GOES-T.
Hey, that's great to hear,
3,
right?
2, 1, mark.
And we have T-minus 4 minutes. We are into T-minus 4 minutes, which is the terminal countdown. Now all the critical systems of the rocket are going for a check, and yeah, we are still go for the launch, and let's hope we get a beautiful launch today.
And topping the vehicles, securing everything, getting things to flight pressure, getting the ordnance control unit armed, the flight termination system armed, getting the vehicle on internal power, which we heard a little while ago that the spacecraft GOES-T is configured and on internal power, ready for today's launch. So we'll be finalizing all these steps, the United Launch Alliance team that we talked about earlier, and they will get GOES-T ready for a liftoff at 4:38 p.m.
And there you can see from that shot of the pad out over the Atlantic Ocean.
Someone says, hi everyone, me and my grandson are watching this, our first launch together. He's so excited. Yes. So, please, just hook up to this live stream right now and just enjoy the launch. You and your grandson would definitely love this launch. So, just stay here and enjoy it. And yes, we are looking for a good. See, this camera was which I was talking about. This is the camera to look out for. This is the camera to look out for, and let's hope we get some good views out of this camera.
Right here at the Cape Canaveral Space Force Station.
Yeah, Daryl, we heard the team, they secured the Atlas tanks to flight pressures, secured that topping. So we see that the liquid oxygen on board that first stage is secure and ready to go. We should be hearing them at about 1:50, securing the Centaur tanks and getting that tank up to flight pressures, getting ready for launch.
Spacecraft is on internal, getting ready to listen for vehicle.
So we are T-minus 2 minutes. Everything looks nominal, and Launch sequence is started.
Securing Centaur LH2.
Securing Centaur LO2.
So there we hear Daryl, vehicles on internal. The auto sequencer has taken over and started the count.
Guys, everyone who are near to the launch pad, launch site, please go out and now just look out for the rocket because there will be some stream delay. So just look out. We are T minus 1 minute and 30 seconds, 90 seconds remaining for the flight. Everything looks nominal. We are go for the launch. Go Centaur, go Atlas, go Ghost T.
115.
Reduce ECS for launch.
Roger. 110. Vent valves locked.
And there we hear the vent valves locked, securing everything to secure that boil off. We should now be coming up on the last call for the range.
1 minute.
T minus 60 seconds.
Range green.
We have a green range, Daryl.
Green.
Everything looks good this morning. Last but not least, we will bring everything to flight pressures and then hear that last status check from Dylan Rice.
And that'll be an exciting moment indeed as we look across the river there to a shot of the rocket. Just a few seconds left.
Yeah, I'm becoming very excited right
there
now.
We verified that all pressures are good, and we are stable at step 3, ready for liftoff this morning.
T minus 30 seconds, guys.
28.
Just sit back and relax.
Verified.
25.
Enjoy the launch.
Status check. Go Atlas.
Go Centaur.
Go Goes T.
And T minus 20, 19, 18, 17, 16, 15, 14, 13, 12,
the final seconds
11,
now.
10,
9, 8, 7, 6, 5, 4, 3, 2, 1.
Ignition. And
liftoff. Liftoff of NOAA's Ghost T, our newest weather sentinel in the sky to help keep us safe here on the ground.
Just see that go.
Daryl, let's listen in as we listen to United Launch Alliance. Rob,
Here's look good.
Who's the flight mission commentator?
View has gone to closed loop control.
Just see that tracking camera shot.
3180 is now throttling down as expected. Engine response looks good. We're now 33 seconds into flight. Atlas is 3 miles in altitude, 0.9 miles downrange distance.
Wow, just wow. Those views were great. I always admire the views of the rocket when it launches.
Throttle back those
now 55 seconds into flight. Atlas is 7 miles in altitude, 4 miles downrange distance, traveling at 1900 miles per hour.
See this tracking shot. This is so cool. I hope we get to see those SRB separation also.
Now throttling back up.
Now we should be approaching the max Q, which is the maximum. Hey, we can see the paint coming off the SRBs.
Atlas is 13 miles in altitude, 10 miles downrange distance, traveling at 2700 miles per hour.
Which is completely nominal. Paint does come off at those speeds. So yeah.
Now at 90 seconds into flight, ULA's Atlas V rocket weighs now just 1/2 of what it did at launch, burning propellant at a rate of more than 2,600 pounds per second.
In 10 seconds, those solid rocket motors on the side will cut off.
Okay, things are looking great, and you should
Beautiful
see
shot
those
from space.
SRBs jettison happening. There
SRBs
you go.
have burned out as expected.
There you go.
We see a good SRB jettison.
That was so cool.
Clear
and
shot of those
Vehicles now
SRBs.
executing
whoa.
steering.
That was amazing.
Here in a few seconds, they're going to throttle back up.
Vehicle performance looks good at this time. Now 135 seconds into flight.
Okay, so things are looking great as expected. RD-180 engines never, I repeat, never ever
The RD-180 has throttled down slightly.
let you down.
Vehicle performance continues to look good at this time. Tank pressures are stable, and Atlas booster battery voltages remain in their expected ranges.
So those Earth shots
Now the upper
behind
stage
the
is
rocket
preparing for
is
its use.
just
Centaur reaction control system is now pressurizing to flight levels.
okay. Right now, RD-180 engines will be throttling down. They are achieving their maximum thrust at this level.
At 3 minutes
time.
and 30 seconds.
So payload fairing separation is the next milestone which will come.
1 minute until BECO. We're now seeing the RD-180 throttle limiting to maintain a 2.5 G acceleration limit.
As I said, has
Standing
achieved
by
the
for
peak.
payload fairing jettison.
Hey, whoa, whoa, see those Flappy Birds go.
Payload fairing jettison.
Good shot.
And those Centaur rings.
RD-180 is throttled back up now. And the vehicle has reached a 4.6 G acceleration limit and will maintain this level through BECO.
And you're looking at animation now.
We've seen that the Centaur has begun its boost phase chill down sequence.
This is an amazing launch. The views are just so beautiful.
Booster about to cut off.
And BECO, booster engine cutoff.
Engine cutoff.
Standing by for stage separation. And a successful stage separation event.
Stage separation. Thrusting
We've
now.
seen pre-start on the RL-10.
And ignition.
And mass 1. We have ignition for the first burn. This first burn of ULA's Centaur upper stage will place the GOES-T spacecraft into a parking orbit around the Earth. This burn will last just over 7 minutes.
Yes, the Hydrolox engine does not have a plume visibility because the plume is so clear.
First stage performed very well this afternoon, and everything's looking good. Those gems.
Activity on the reaction control system as it begins its periodic firings to maintain thermal control conditioning.
Yeah, those GEM 63s performed well, solid rocket boosters, and RD-180 performance well. What I really liked was when we saw the payload fairing come off. That was a great shot from the camera. Saw the payload fairing come off, and then most people probably noticed that little half cylindrical come off after payload fairings.
Yeah.
That was what we call the Centaur forward load reaction deck. Because the fairing, the 5-meter fairing, encompasses both Centaur
As expected.
and the GOES-T satellite, there's a load ring that's inside the fairing around Centaur to help keep that 5-meter fairing from flexing. So that's what you saw when you came off there.
I was wondering about
And the
that.
engine response remains nominal.
And so those views of the rocket engines and thrusters working, this is so cool.
All right, we're going to keep an eye on this burn and listen in. But in the meantime, we'll send it back to Megan out at the host desk.
If you're just joining us, welcome live to Kennedy Space Center in Florida, where we just saw GOES-T launch from just behind us at Cape Canaveral Space Force Station. And guess what, everyone? I just found out that this was Kevin's first launch.
It was.
How was it?
It was super exciting. Almost a proud moment as an American, 20-year Air Force vet, and to be able to see this was awesome. Absolutely awesome.
Yeah, I'm so glad to be here. It was very fun to watch you react. Like you were like you were like a kid. Like, oh, I have to take this. Oh, wow. It was great.
Absolutely.
It was great. So what's next for this mission?
Well, the wonderful thing about this, now that we've had a successful launch, we have about 12 days before it actually reaches geostationary orbit. So at that point, that's when we'll start our checkout phase. We'll be looking for the data to come down from the spacecraft to make sure everything checks out, that the images are correct, all that kind of stuff has to work its way through.
And, GOES is NOAA's latest weather satellite, as we've said. We've been launching GOES satellites together for nearly 50 years. I mean, there's been so many advancements made in between those times.
There have. And, I like to remind people that, this particular satellite in the series is really an evolutionary step, much like cell phones. Or when we talk about, hey, do you remember when we used to use landlines and rotary phones? Well, think about the leap we've taken from then to the cell phones and the capabilities that we have, much like that with our satellites.
Yeah, I know. I feel safer knowing that GOES satellites are up there. And now I'd like to bring in NASA's Leah Martin, who got to watch the launch with our agency's Deputy Administrator. Leah.
Hi, Megan. Like you said, I am here with Pam Milroy, NASA's Deputy Administrator. And what did you think of that launch? So exciting.
Thank you so much,
It was
appreciate it. And
I don't know, I always just feel this electricity when a launch
it happens.
goes up. You're like, wow, people can do this. This is just the power and the majesty of it as you see it lifting into the heavens. It's always exciting.
And, you know, hours and hours and months of work that go
Yes.
into it. Absolutely. So, you know, NASA's vision is to expand knowledge for the benefit of people here on Earth. That's the heart behind everything that we do. How does this mission fit into that?
This mission is a great example of our mission in a lot of different ways. I think one of the most powerful things that we do at NASA is we partner with others to maximize the benefit of the things that we do. So this mission to launch the GOES-T satellite will enable us to have cutting edge capabilities that are looking down on the Western Hemisphere, the western part of the United States, to ensure that the data that goes into the NOAA models around weather are optimized, they're up to date, they will affect people's lives, whether it's farmers or protecting from wildfires. But what's interesting is we're also going to take that data because we have Earth scientists who are modeling our Earth as a system and climate far out into the future. This isn't an operational weather, which is what NOAA's mission is. They do it very well. But we take this data and we also use it for the benefit of science. So it's a really synergistic partnership.
And you just mentioned climate change and monitoring the changes because that is a priority for NASA.
It is. It's one of our top priorities. We are already doing a significant amount in this area. Earth science and looking at our own Earth has always been an important part of our science mission. Interestingly, we also study other planets in the solar system, such as Mars, which we believe was once wet and had more of an atmosphere. And so the question is, how did it get the way that it did? And how do we make sure that does not happen to our planet? So it's a critical part of our mission.
Well, we're hoping that the information that we get today can feed into the future missions of tomorrow. If nothing else, we'll certainly know the weather. Pam, thank you so much for joining us today. We really appreciate it, and we hope you enjoyed the live.
Exciting day.
Megan, back to you.
Thank you, Leah and Pam. And Kevin, GOES-T doesn't just forecast.
You can actually see right now the perigee is negative, which means it's still inside the Earth. So it has not still achieved the orbit, but it is going good right now. So that's what we want.
Yeah, absolutely. This past year has been kind of a revelation in our capabilities to view volcanic eruptions. In particular, probably the most spectacular example will be the Tongan. But what we also have is another example in the Caribbean where you can see not only the amount of ash that goes up, but the area that it covers. And as a result of that particular hazard becomes an aviation hazard in particular.
Yeah, you can see all the
You can
smoke there.
actually
You know,
see the sonic boom also here in that GIF. That was great.
and we had to ground hundreds of flights because of it. So really, GOES helps decide whether or not it's safe to fly.
They do. Again, NOAA's partnered with the FAA, and they provide them with those volcanic ash, both forecasts and projections for where that ash could go.
All right, we're now approaching another milestone in the ascent. Daryl and Mick, back to you.
Thank you very much, Megan. And we continue to burn, continue to get good numbers as we monitor the flight of the Centaur and GOES-T.
Yeah, things are looking really great on this flight, and coming up on MECO 1 of that Centaur engine as Centaur continues to perform nominally. We've heard pressures and everything look great.
EU system has gone open loop.
Here in about 10 seconds, we'll have
Standing by for the end of the burn.
Apogee have interchange.
Main engine has cut off.
There you go. That completes that first burn. And so now we go into about an 11-minute coast phase, Mick.
At this time, the GOES-T spacecraft and ULA Centaur upper stage are in an unpowered coast phase that will last approximately 11 minutes. The coast allows the vehicle to move to optimal orbital position in the orbit prior to beginning the second main engine burn.
And what you're looking at is animation that is tied directly.
Guys, if you just loved the Liftoff, please like the stream and subscribe for more, because here you will see those lifts off quite often, and they are very beautiful to see also. So if you want to support me in my endeavor to make people aware about these rockets and space and just science in general, please support me by becoming a member or a Patreon, and super chats are always enabled. So Yeah, right now things are looking great for this launch, although this is a very, very, very long mission because they,
Of your
yeah, 3
milestone
hours.
list between MECO 2 and MES 3, that's 3 hours. It's short there on your screen, but it's a long one. As you're looking at the animation, we are in orbital darkness. The sun is blocked out, and so the animation is reflecting that at this time, so we can't see the Earth behind it. They give it that kind of accuracy in terms of its look, so the spacecraft is in total darkness, but when it comes out and those solar rays unfurl, it'll have some power. All right, we're going to send it back to Megan for now and while we coast, but we'll be back for that second burn.
Thank you both. Now, GOES-T will warn us about weather here on Earth, but also space weather. But what is that, and how does it impact us here on the ground? Take a look.
So the sun, looking here from the ground, seems very constant and quiet. But actually, when we look at it from space, we can see it's quite turbulent and active. Space weather is activity on the sun and in a near-Earth space that can affect our technological infrastructure and society. The sun is constantly spewing out a stream of particles called the solar wind that goes out into the solar system. And it affects us here near Earth, where we're protected by a magnetic field. The interaction between the solar wind and the magnetic field can cause space weather. The Carrington event is the largest storm we've seen in recorded history when we're looking at space weather. But every solar cycle, which repeats about every 11 years, one estimate estimates that there's a 10% chance of getting a large storm like the Carrington event that could impact us here on Earth. But we see solar storms almost all the time. And these storms have an effect on our technological infrastructure. Solar storms can cause activity in Earth's atmosphere and magnetosphere that can damage electrical power grids that power our communities, interrupt radio and satellite communications, and can cause our GPS navigation to fail. NOAA is working with its international partners to ensure that we have different vantage points where we can observe space weather. Our space weather observing infrastructure from space includes the NOAA Discover satellite and the NASA ACE satellite that are stationed upstream of Earth to give us a first buoy measurement of the solar wind. It also includes the ESA-NASA SOHO satellite and the NASA Stereo satellite that image the sun and also make coronagraph measurements of the outer atmosphere of the sun, the corona, that can tell us when large explosions happen off the sun. We also observe the sun and the Earth's magnetic field from the geostationary location with NOAA's GOES.
Come on.
So the way we use the space weather information from satellites and from the ground is to be able to make forecasts and predictions, just like we do with hurricanes and terrestrial weather. We observe the sun and look for activity and see how it develops and see if it's going to culminate into a large explosion that can affect us here on Earth. NOAA is working with its international partners to expand our observing capability. We're committed to observing along the Sun-Earth line. So we're going to do the imaging of the sun and the upstream buoy measurements of the solar wind along the Sun-Earth axis.
That is the case, Wildflower. That is always the case.
The more we understand about the sun, the more we can prepare for it and become, just like we are a weather-ready nation, become a space weather-ready nation. And as we look forward to humans exploring out into the solar system and advancing our space commerce activities, space weather becomes more and more important.
See, Bill Gates used to, already used to warn about the pandemic situations that it can happen anytime and we should be prepared, but nobody listened. And now this has happened, and now everyone is, everything has changed. So this is how things work. A big event has to happen before the things changes. And talking about the, power grids, if you are wondering like how those power grids get affected because of the geomagnetic storm, well, the answer is simple. If you have heard about the electromagnetic induction in your school's physics, if you have studied about that, then that must have answered your question. uh, what happens is when there is a very large amount of those coronal mass ejections, basically the coronal mass ejected from the sun, that affects the magnetic field of the earth. Due to the changes in the magnetic field of the earth, the change in the magnetic field induces the current in the conductors. That's what is the electromagnetic induction law, right? Wherein that's how generators work, where a mechanical magnet moves, and that mechanical magnet which moves generates electricity. Same thing happens here. The huge magnetic field of the earth, that changes, and because of that the induction of electricity happens in each and every conductor. Satellites get affected, the power grids get affected, and almost everything metal gets affected on earth. And it depends on how the potential difference changes, like how much they will be affected will depend on how well they are conducted. Like if they're grounded, then they will be affected the most. So yeah, that's how those things work. And that's why space weather becomes such a crucial thing to for us to monitor, not only on earth but in space also, because if we can monitor the space weather, then we can actually plan our human space exploration to moon and Mars and beyond and whatnot.
Other different phenomena that we can look at in the Earth system, but also out at the sun, for example, to understand what's happening with solar storms that impact us here on Earth as well.
So really it's science for today while we're facing forward to science for tomorrow.
It absolutely is. You think about how many years it takes to build a satellite like the GOES series, and you want to make sure that you're putting the state-of-the-art science and technology in the satellite that may not launch for 5-10 years. So what do we think the scientific capabilities will be in 5 or 10 years? And let's start working in the laboratory now to build those new sensors and those new operating systems.
It's incredible to think that, in just another decade or more that we could be here talking about a completely different system. Thank you so much for joining us today. We really appreciate it. Megan?
Really interesting to hear about everything that's happening that we can really all learn from. It's been about 21 minutes since launch. Dale or Mick, we're coming up on that second burn now.
Yeah, we sure are. And thank you, Megan. Back inside the Atlas Spaceflight Operations Center, Mick Woltman here with us, LSP engineer. We're heading towards orbital sunrise. We've been in a coast phase right now, heading over Africa, West Africa, across the southern coast there. And we've got a burn coming up in just about a minute.
Yeah, this second burn is very important, as it'll get us out of this park orbit around Earth and get us on our way towards that geostationary orbit we want to head for GOES-T to allow them to do their science and protect us with all those instruments they've got for weather realization.
You're looking at animation now tied to real-time telemetry, the Centaur on the left part and GOES-T on the right part, as it chases the sun. Mick, chasing orbital sunrise here in just a few seconds, and ULA kind of basically simulating that with a more lighted landscape.
And there we hear pre-start on the RL-10 coming up from Rob Kesselman. Data showing that RL-10 is getting ready to ignite for this second burn.
This is actually the ULA which is happening, and should be having an ignition now. There you go.
Ignition. That's 2.
All right, main engine start number 2. We have advanced across the bottom of your screen where we have all the milestones listed. We're going to burn for about 6 minutes. As you mentioned, Mick, this is really hitting the gas
PU
and
has
getting
gone to
out
closed loop
deeper into
control.
space.
Yeah, absolutely. This is going to be the burn where we get GOES-T headed out where it needs to be, and then
this burn will transfer it from a low Earth orbit to geosynchronous transfer orbit. So you will see the apogee to reach at around 36,000 kilometers or so. So yeah, just look out for that apogee altitude increasing 1,300.
I'll take you back, of course.
Whatnot.
We know that this satellite here can have ability to map lightning. It's got high technology on there that's very valuable. But also, when it was on the ground,
10 thrust chamber
it could have
pressure.
been it could have been suspect, rather, I should say susceptible. Sorry. Susceptible to lightning when it was on the ground. But Launch Services Program developed some technology to help protect it. And I was fortunate to go out to the pad. This is something that you do a lot, go out there to the launch pad. But I was invited to go out with one of LSP's young engineers to share and install this equipment that helps protect against delays. Let's check it out.
Okay.
Hey, Daryl.
Good to see you.
Good to see you too.
Hey, thanks for having me out. So this is it.
This is it. This is the PLI.
The NASA Portable Lightning Instrumentation. I see it right here. You're going to take it up there all the way where the top of the rocket is?
Yeah, right around where the payload fairing is, level 5.
All right.
That's where we're going.
Well, you need a hand?
Yeah, come help us.
Now that we're inside the VIF and we're about 13 stories up, tell me a little bit about this box. You've got some, looks like some sensors here.
That's right. So we got the current probe, which is over near the rocket, and we have 3 more sensors over here. This one is an electric field sensor. This one up here is a magnetic field sensor. And this little one over here, that's a GPS antenna. That's how we get it, make sure our data stays synchronized in time, so that we can correlate that data to all the other lightning detection networks in the area.
So what happens if there's a lightning strike somewhere nearby? What does this do?
So if it's close enough to cause any interference in this area, these field sensors will pick it up first. And they'll cause the entire system to take a snapshot of that data and record it.
And how is that helpful?
We'll know what the peak of it was, we'll know how long the transient lasted, we'll be able to calculate how much energy traveled through there, we'll have a lot more information to work on.
Small box, big rocket, but it's got a big role in the whole scheme of things.
It's got a big job, that's for sure.
So we can see those lightning towers out there, and ULA tells me that that protects the rocket when the lightning strikes. So why do we need the PLI?
Yeah, so this system over here, we call that the lightning protection system. That's designed to protect it from a direct lightning strike. That means the lightning is attaching directly to the rocket, and we're concerned about, a lightning strike out there in the ocean, maybe just a mile away. And the energy in a lightning strike is so intense, it creates these very powerful magnetic and electric fields. And those are the things we're concerned about, because that magnetic field can come through and couple into the umbilical cable. It's a huge loop. It makes a big old loop, and that's the current we're looking for with the PLI.
Has the PLI ever prevented a long launch delay for a previous mission?
Mars 2020 was where the data from the PLI gave the spacecraft team the confidence to go ahead and launch.
So there was a lightning strike around the Mars Perseverance rocket.
That's right.
And you saw it?
And we gathered that data, yep.
And it launched on time.
It did. And it's up there now.
That's right, on Mars.
That's right.
Well, that was a lot of fun to go out there, and Alex, of course, was great to have me out there at the pad. But this technology, really helpful when you have a lightning strike. It was connected up inside the VIF when GOES was inside.
Yeah, Alex and the team have done a great job with that. They've been studying this for years, and they came up with this PLI and working with our commercial partners, they've been able to install it, like you said, on the VIF for the Atlas V mission. And as Alex mentioned, we actually used it during Mars 2020 to help us verify some information, so we didn't have to go back and retest anything, and it actually
Well,
saved
well,
the
well,
launch.
Nihilist
So,
human, you asked a very
the
interesting question actually, and that could a big and fast enough rocket create lightning? If you will search on internet, there is something called rocket triggered lightning, which is a thing. So here what it does is a lightning rocket is a rocket that unravels a conductor such as a fine copper wire as it ascends to conduct lightning charges to the ground, create artificial lightning. So to answer your question, yes, we have a Miko 2 now, and yes, a rocket fast enough and of a proper size can create lightning, and it does not this is the artificial lightning which we are creating using the copper wire, but normal rocket launches can also trigger lightning, and it has happened in the past that a rocket launch has created triggered lightning because the static electricities uh, is a thing, because you are actually trying to those static electricity is very notorious, I must say that. So you don't know where the static electricity is being built up, and that's why if there is some sort of static electricity inside a rocket, which you should not be having, but if there is anything, then yeah, it can cause some sort of lightning.
Bottom of our progress bar to a countdown clock to show you and represent that 3 hours. When we return, we should be out of Africa and near the coast of Australia. So we're going to do some cruising.
Yes, we are. This, like I said, longest part of the mission, but very much needed to get Ghost T where she needs to be.
All right. For now, that's going to wrap up our coverage for this initial part of the mission. We will be here throughout, listening to the loops, monitoring the launch team. Mick's not going anywhere either.
Nope.
He's going to lock it down, and of course, we'll give you all the updates as we go along, and then rejoin you finally after the 3 hours. But for now, we'll send it back to Megan and Kevin.
Yeah, as I just mentioned, GOES-T will now coast for about 3 hours before spacecraft separation. We will stay on air for this coast phase to bring you those live animations you've been watching, as well as commentary from Daryl and Mick. You can expect those hits at the top of every hour at 6 and 7 p.m. Eastern Time. In the meantime, we have some fantastic art to show you from kids around the world as part of NASA's space.
So guys, I don't think so I'll be able to stream it for that long. So I think I'll be ending this stream because it's already like 3:40 a.m. here, and I need to wake up at 6 tomorrow. But yeah, so Saturn V did it in Apollo 12 mission. I don't remember actually. It may have done, but I don't remember. For regular rockets, the plume ionizes the air and the lightning follows the trail of the ionized air. Yes, that is a thing which I missed. The plume can ionize the air, and that's what you need for lightning. You just need some difference in charges, and that's what will trigger the lightning. So the plume can trigger the lightning, and yes, that can happen. You are right about it. Consider that airplanes don't all get dropped from the sky all the time, but do get strike plenty. It's technically shielded and just passes around and through the screen. Shouldn't make a rocket fail. Yes, actually, shielding anything from lightning is very easy, and this is a very common misconception also, that to shield a particular instrument or something from lightning, you just cover it with the non-conductive materials. Whoa, okay. So you just cover it with non-conductive materials and like rubber and the thing which actually does not conduct electricity. But that is not how you work with electricity. See, the thing with the electricity is that it carries power, it carries energy, and it has to dissipate that energy. When you have a non-conductive material and the lightning strikes it, then that energy is dissipated on that area where it has struck, because it cannot dissipate, it cannot travel. And because of that, the most harmful and dangerous situation is for a person is when a person is wearing a rubberized raincoat and the lightning strikes him or her. That is a problematic situation. Okay, it's always and always good, and it is the only way actually to protect yourself from lightning is to wear a metal coat. Yes, yes, it is how you protect yourself from lightning. It may feel like it may feel like it is a very, you know, different opinion, but this is how it works. Okay, because then the lightning has the time to travel. Basically what happens is when you wear a metal coat or metal something like that, the lightning strikes that metal, and metal is, you know, conductive material. Lightning then dissipates through that metal to the ground, so you do not get anything out of it. And lightning or the electricity has this property that it travels in such a way that it will always find a path wherever there is you know, low resistance. So therefore when you are wearing a metal covering or metal body or metal armor or whatever you want to say, the lightning has two paths, whether to go through the metal or to go through your skin. And your skin has like 50 kilo ohm resistance, and metal does not have any resistance. So lightning always tend to take that path which has less resistance. Electricity takes path which has less resistance. Therefore, you don't get struck with the lightning. You will be safe. So yeah, that's how these things works. And for aircraft also, aircraft are made up of uh, very conductive outer material, so that whenever there is a strike, the lightning can just pass through that metal and you know, to the earth. That's how they are also shielded. Thank you so much, John Wilson. I really appreciate you moderating the chat. You always does that. I really appreciate your efforts. Thank you so much for all you do. And yes, path of least resistance, exactly. Faraday cage like condition, highly conductive on the outside, so it avoids the interior. Exactly, exactly. You want non-conductive space between the metal, or else roast human in night sub. You yes, I mean, obviously, but non-conductive material is there between the metal and that. I mean to say, you know, the air is there, your skin is very non-resistant, but the sweat is not. So if you are sweating a lot in your armor, then you are on. Okay. So Ariane 6 literally gets off the ground this year. This month will be all about new member of the Ariane family who would be like there, who would like to be there to watch it soar into space. Me, pick me. Yes, now Ariane Space and Ariane Group has this problem which they have to solve. Wait a second. Uh, yes, I was saying, and Ariane Group has a big situation here, you know, the Ariane Space was operating Soyuz as its launch vehicle for quite a long time, and most of the task was done by Soyuz launch vehicle. And now the Roscosmos has basically taken off its crew from Kourou, so there will not be any Soyuz launches from happening from Kourou, but that can happen from Baikonur Cosmodrome and all. But I don't think so. Ariane Space will be launching those Soyuz rockets. Yeah, that is a thing. And there's been one which is very popular today. And this thing. NASA Inspector General Paul Martin tells Congress that NASA's first four Artemis missions will cost an unsustainable $4.1 billion each, with the price tag based on only the production cost for SLS or iron and the ground operation, just the production cost and not the operation cost. Just it is just so much expensive. Was supposed to be like $2 billion per launch SLS, and that was that itself was very expensive, and now it is like 4.1 billion. Latest estimates have suggested $4.1 billion per launch. Dude, NASA ISRO has the annual budget of $2 billion. Annual budget of $2 billion. And not even think in its dream to be doing such things there. And yes, it is definitely very much unstable. And with the Starship coming into operation, I don't think so we'll have like many SLS going to space. I hardly suspect like just the initial stages, maybe Artemis 1, 2, and 3 would be supported by SLS, and then it would be shifted towards the Starship, because it is the how $4.1 billion per launch is so expensive, and that is just the production, the operation cost. Just wow. And talking about these things, well, yes, there have been certain developments in Russia, and you can see now the Russia has announced the independence, independence in matters of space instrumentation. So everything will be developed in Russia from now onwards regarding aerospace. So that's what they have announced. A new dawn for a Russian aerospace industry, maybe. And one more thing which should be seeing is this one. Um, Russia announced that that is prepared to use the RD-180 without Russia, because Russian engineers will not be available for the Atlas 5 launches, and Atlas 5 uses RD-180 engines. So what he did was that you can say this ship will be launched into space on an Atlas 5. He's talking about the Starliner mission. Rocket with the RD-180 propulsion engine in the first day, but already without the supervision of our specialists. Well, let's pray for our American friend. That's what he thinks. And here we have a savage reply from Tori Bruno. We prefer to have them available for consultation in the event that the engine might do something unexpected, but we have been flying these for years and have developed experience and expertise. So I asked this question him to please clear the doubts of Mr. Rogozin, and he did a very well commendable job here to clear his doubts. Basically, what he meant was that now they have been flying the Atlas 5 for so many years now, and Atlas 5 has like 100% launch success. It's a very reliable rocket. Yes, they would prefer them to be available for consultation if anything unexpected happens, but no, they have the experience and the capability to launch the rocket without them too. So yeah, they have been like looking for to them for such a long time. So yes, that is one thing which you need to see. This is the many things are happening in Russia's aerospace industry, and let me tell you one thing is, with the way things are proceeding, I can't see there are two types of things which can happen right now. Before the war, we had many things coming out of Russia regarding aerospace, and now all the sanctions and everything will be in place, and so Russia will be excluded from the world of aerospace and whatnot, um, excluding the ISS, because that is a very critical hardware and you can't just separate them suddenly. So that can continue happening, but these launches, the engines will not be supplied from Russia. So now Ukraine, I can see that happening, that Ukraine will emerge as the next big power of aerospace industry, because we used to have certain rocket engines and rockets coming out of Ukraine, like the Antares as well as the Astra rocket. The first stage of the Astra rocket is developed in Ukraine, and now Astra has like 2 rockets right now ready for the launch, but don't know what is there in future. But I can say that it might take some time for it to stabilize, but Ukraine is having a good, um, you know, career ahead in aerospace. I must say that. But in Russia, well, if you think about Russia, Russia has like a new dawn in aerospace industry, because Russian aerospace industry was literally dying. I am saying it. It was literally dying, and with these things, it may survive and may like emerge again. So you just don't know what can happen in interesting times ahead. Okay, so guys, I think that is pretty much about it, and this is a very interesting um, thing which they have developed. Spin launch, right? Thing which is accelerated so uh, highly that it can be launched into space by just spinning it very fast. Not a railgun concept, but not a railgun concept. How railgun works, but yeah, eventually railgun also spews out what should I say, something metallic, a very high speed, and here also it is doing similar thing but different mechanism. Ghosty launch from the Cape a short while away. We can actually see the launch of the Atlas V from the Ghosty satellite. That is so cool, right? A Ghosty satellite actually um, taking pictures of the ghosty satellite being launched. A ghost satellite taking picture of a ghosty satellite being launched. That is great. So, guys, that's what we do here. If you are just joined in, please, please, please hit that like button. Just like kar do. And, just hit that like button, subscribe, and we'll meet again for another launch. And now we will have a certain, what should I say, silence in launches, at least on this channel, because the next launch scheduled are of Starlink and the OneWeb launch. And I am very surprised that OneWeb is actually launching. I don't know how they will, you know, do those sustainably, do those, because it will be a very big PR backlash for OneWeb. And they have already made payments for the first generation of the satellites. Like there are 6 Soyuz launch scheduled, and they have made the payment for all of them. So I don't know how the things would look like, but yes, this one is happening because the rocket was assembled, fully assembled, and was just waiting for it to launch. So next launch coming up is it's to ISS only. The major launch is to ISS, and we are also we may also see the Axiom space mission, which is the first uh, commercial space mission to ISS, fully commercialized space mission to. So that would be great to see. We may also see the Tianzhu 4 mission to the CSS, this Chinese space station, and PSLV launch. You can also see that. And there are many launches scheduled for March, but we just don't know the date yet. So just look out for some. So there will be a while now until we meet again, but it's always good to have you back after a short while. So I'll be looking forward to that. So until then, guys, just please hit that like button and do support me if you want, because it really helps me by becoming a member or a Patreon. And a shout out to every Patreon member I have, Madville and Null Unit, for their constant support for sponsoring the streams that I am doing. So yes, thank you so much for that. And so much to all the moderators also for doing such a good job. So until then, this is Priyanshu Royala. You just saw Rocket Gyan. Stay safe, stay healthy, and